Alright, what we're looking at in this video is how to apply L'Hopital's rule for indeterminate forms. So L'Hopital's rule deals with limits of functions, and what we're going to focus on in this video are when we take a limit and we get 0 over 0 or infinity over infinity. So these are the two main indeterminates. Can't tell what the values are, so we have to do something special, and that's going to be L'Hopital's rule. So L'Hopital's rule says that if we take the limit of two functions divided, it's going to be equivalent to the limit of their derivatives. So it's a really cool rule that helps in a lot of situations, makes problems a lot easier. So that's what we're going to look at. So first problem here, we have the limit as x approaches 1 of ln x over x minus 1. So we know with limits, the first thing we always try to do is plug in the value that it's approaching. So we go in, plug 1 in, we get natural log of 1, which we know is 0, and we get 0 on the bottom. So we get this 0 over 0 situation. So L'Hopital's rule can be used in this situation. So we have 0 over 0. We can take the derivative of the top and derivative of the bottom, and then take the limit again. So we have limit as x approaches infinity, or not infinity, 1, sorry. I'm so used to doing those to infinity. So we get 1 over x divided by derivative of the bottom is going to be 1. So now we go ahead and plug in 1 again, and we see what we get. So 1 over 1 over 1 is 1. Okay? So if we were to graph this on a calculator, this original function here, this is what we would get. And as x approaches 1, we have this spot right here. So the y value that we're approaching is 1. So we can tell it from a graph sometimes, but we need to prove it using L'Hopital's rule. Okay, so x approaches infinity for e to the x over x squared. So what we're going to do is plug in infinity. We have e to the infinity, which is infinity, and then we have infinity squared, which is infinity. So we have infinity over infinity situation, so that's indeterminate. So we can use L'Hopital here. So we have limit as x approaches infinity of derivative of the top, so we know that's just e to the x, over derivative of the bottom. So plug in infinity, we get e to the infinity over 2 times infinity, so we get infinity. So we're still at an indeterminate. So the nice thing is we can continue using L'Hopital's rule until we get to an answer. So we can go ahead and take derivative again. Derivative of the top and derivative of the bottom. So we know derivative e to the x, and then derivative of the bottom is going to be 2. So we get this situation where we have e to the infinity, which is infinity, over 2. Okay, so remember when the top is infinity, top's growing faster, that's just approaching infinity. If we look at our graph, we're approaching infinity on the x. What's the y doing? So if we could zoom out, this is approaching infinity. So the infinity would be the answer here. Okay. Next one, we're doing limit as x approaches infinity again of this guy. So what we're doing, we're plugging in infinity. So we get 4 times x, or infinity squared, minus 5 times infinity, plus 2. So that's just infinity over e to the infinity plus ln to infinity. So we get infinity. Okay. So we have to know where our graphs are trending towards, like for ln x and e to the x, and all of our basic graphs that we've been using. We need to be able to tell where they're going. So we get infinity over infinity, so we can go ahead and take derivative. So we have infinity. So take derivative of the top, get 8x minus 5 over 5 times e to the 5x plus 1 over x. Go ahead and plug infinity in again, so we get infinity on the top. We would get infinity plus, well, 1 over infinity is 0, so that would be infinity. So we get infinity over infinity again. So go ahead and do another round of L'Hopital's. So we get 8 on the top. We end up with 25e to the 5x minus 1 over x squared. And we plug it in, so we get 8 over, that's going to be infinity if we plug that into the e, and then that's going to be 0. So we're subtracting 0, we have 8 over infinity. So bottom is trending towards infinity. We have a constant on the top, so that's just going to be 0. Okay, so I'm going to go ahead and make another video of the other indeterminate rules, but the idea here helps explain why we learned before, where we can look at a function and look which grows faster when we're talking about limits. At the very beginning, we know that the bottom is growing faster because e grows faster than a square. Okay, that's where the idea comes from, and that's why it works, is because of L'Hopital. So, I mean, we could have probably looked at this at the beginning and said, well, this is going to be 0, but this is the proof. This is what we have to do to prove that. So, and then some of them aren't as clear as others, but that's what we're dealing with here. So I'm going to go ahead and make another video here, so go ahead and watch that.